Hello everyone. In this video, we'll focus our discussion on the molecules where there are two chiral carbons. Already we have discussed about the compounds or about the molecules where there is only one chiral carbon, and in those cases we have found that there are two stereoisomers possible and their relationship is enantiomers, right? Now we'll see what are the different stereoisomers possible when a molecule is having two chiral carbons. Let us consider this molecule where there are two chiral carbon, right? This is one and this is the other. This carbon is attached with a methyl group. Suppose this is a methyl group. C carbon is attached with 3 hydrogen. Then this is a hydrogen, and this group we have assumed that this is a OH group, and this is another carbon, right, which is again attached with hydrogen, and then suppose this is a amino group and this is OH group, right? That means this carbon is attached with 4 different atoms or groups, and therefore this is a chiral carbon. Same way, this carbon is also attached with this hydrogen. This is OH group, then this is, suppose this is the NH2 group, and this portion, right? And therefore this particular carbon is also a chiral carbon. Therefore here there are two chiral carbons. This carbon is not chiral, right? Because this carbon is attached with 3 hydrogens, right? What is the condition to become a chiral carbon? It must attach to it 4 different groups or atoms. And here in this molecule there are two chiral carbons. Now we will determine the configuration of both the chiral carbon. Let us first consider this carbon, right? Now according to CIP, how we have to visualize the carbon, this chiral carbon, the lowest priority group or atom should be away from the viewer. Now let us determine let us assign the priority of the 4 groups attached with this particular carbon, right? See, this is attached directly with a carbon which is attached with a hydrogen. Then this is hydrogen, this is O, right? This is carbon, right? And therefore this will get the first priority, this will get the 4th priority, and there is a tie between this carbon and this carbon. But this carbon is attached with hydrogen, then amino, and then OH, and therefore among this carbon and this carbon it will get higher priority. That means here this is first priority, this is second, this is third, and this is 4th. Now according to CIP rule, this 4th priority group should be below the viewer, right? It should away from the viewer. Yeah, 3 group exchange we have done, right? Then see, this is 1, this is 2, this is 3, 1, 2, 3. What is this turn? This is the clockwise turn. Therefore this particular carbon's configuration is R, right? Okay, then we will determine the configuration of this carbon, this particular chiral carbon. It is attached with, directly connected with a nitrogen. Then this is oxygen, this is hydrogen, and this is carbon. Okay, then which will get the highest priority? Definitely this oxygen will get the highest priority. This is 1, right? Then nitrogen will get the second priority according to its atomic weight, right? Then carbon is 3, and this is what, 4. Then this should be below the plane. Yes, this is below the plane. Okay, then this is 1, right? 1, 2, 3. 1, 2, 3. What is this direction? This is our again R. That means this is R and this is also R. Okay. Now this molecule of which we have determined the configuration of both the carbons, these are R and R. If we place in front of a mirror, then what we will find that this will be the mirror image of the first one. And since this is RR, therefore they must be SS. And if we try to superimpose with one with another, then what we will find that they are non-superimposable with each other, right? And Therefore, we can conclude that they are enantiomers. Now, this type of molecules where there are two chiral carbons, then they can exist as 4 different stereoisomers. These are the two already you have seen. Then one more it can exist. This may be this one, right? Now, what is the configuration of these two? Already we have find that the configuration of this is R, and this, if we observe, then this will be the mirror image of this one, and therefore this will be what? S, right? And if you see the configuration of this carbon and this carbon is same, right? Then if this is R, then this will also be R. That means this is RR and this is our SR, right? Now this SR, if we place in front of a mirror, then what we'll get? We'll get this one. We'll get this one. This one will be its mirror image. And we have found that this is S and this is R. And since this is S, therefore this will be R, right? And this will be S. That means this is SR and this will be RS. That means these two are again mirror image of each other and they will not superimposable with each other. That means this is also a one pair of enantiomer. That means a molecule where there are two chiral carbon, in that case, two pairs of enantiomers are possible. Now what we have observed that for a molecule when there are two chiral carbons, then two pairs of enantiomers are possible. This is the first pair, this one and this one. They are non-superimposable mirror image of each other. They are one pair of enantiomers. This is also a pair of stereoisomers which are non-superimposable mirror images, and therefore this is a pair of enantiomers. That means two pairs of enantiomers are possible. Then the question is, what is the relationship between this and this? They are stereoisomer of the same molecule, but they are not mirror images. The relationship is called diastereoisomers. This is a pair of diastereoisomer and this is also a pair of diastereoisomers. That means this is one pair of diastereoisomer, this is one pair of diastereoisomers. Then again with this molecule, this is not superimposable mirror image, they are again diastereoisomers, and this also their relationship is diastereoisomer. That means there are four pairs of diastereoisomers possible.